will try not to make this another 10-minute video, but it's just so fun talking about GeoGebra and geometry, so I'll do my best. But in this video, we're going to look at one additional question, and this time we're talking about when the sequence is a translation and rotation, and here's how I know. So let me look at the link, and I'll show you again where these images came from. I'll walk you through that again. So here's the link that will take me to what this picture looks like, or originated as, in GeoGebra, and I'm going to do the same kind of experience again, where here it says triangle PQR maps onto triangle MNO. So I'm going to start with my my pen tool, and if PQR maps onto MNO, that means PQR is the pre-image and MNO is the image. Okay, and then second, after I decide what came first and what came second, the second thing is to decide what's the orientation of both. So I'm going to go PQR around here, and that one is going the opposite direction of the clock. So this is a counterclockwise orientation. And then MNO, also MNO goes the opposite direction the clock hands go. So this is also counterclockwise. So you can see that in this case, my orientation did not change, and that's why I know a line reflection didn't happen. But it wasn't just a translation that must have done this, and we can learn about ways to figure out a center rotation. There can't be just one center point that takes me from here to here. So I'm going to first translate, and then I'm going to rotate. But before I do that, let me again not get rid of these, but I'm going to just kind of minimize them so that they're not so boom in our face here. So I just want to, I like color coordinating. So I'm going to make this like this and this like this. Okay, so here's what's going to happen is I'm going to decide what my translation looks like. So I can map one of the points of the pre-image onto its corresponding point in the image. And I have a choice. I can put P onto M, or I can put Q onto N, or I could put R onto O. Now, I think P and M are the closest points, so I'm going to map point P onto point M. So if I translate by vector, I'm going to take the pre-image triangle, I'm going to move point P onto point M, and boom, there it goes. So now let me again just kind of make this a little different looking. I'm going to go with the dotted one, and I'll make this, how about green? So here is the image of PQR to become this triangle here. Now, by mapping a point onto a point, that makes this right here must be the center of rotation, and I can prove it to you by drawing a couple more circles. If point M or point P prime, and they're both the same, if that's the center of rotation, then one circle should be able to go through both this point and a point Q and point N, there's that one, and then I can have another circle that goes from point R prime and point O. So that kind of proves that this point right here is the center of rotation. But I don't need both circles. I'm going to get rid of one. I'll just keep the one for now. And with that circle, that's not the highlight of my whole picture either, so I'm going to make that a dash segment. And what I want to do is I'm going to say, okay, with my pen tool, this point Q is moving along this circle until it maps onto this point N. Now, do you remember what direction that the points must rotate if you wanted to say what's the positive direction of the angle? The positive direction is always in the counterclockwise direction. So I'm going to take point Q, I'm going to go counterclockwise, that's this way, to get to point N. So how far is that rotation? Well, let's measure it and make sure that we have an accurate measurement of this. So let's go ahead to the measure tool and measure the angle from this point to this point to this point, and it tells me, boom, right there, it's a 90-degree rotation. So I had to translate first from point P to point M. Now, if I zoom in a little bit, I can figure out how far that was. So I moved to the left from +1 over here to -3. That's 4 units left. And then I moved up from -6 to -4. That's 2 units up. So I had to go 4 left and up 2 first, and then I did a 90-degree rotation about point M. So take a look at my notes. So here's the picture. I did it the exact same way. And I said, first, I took triangle PQR. I made triangle P prime, Q prime, R prime by doing a translation where I moved X's to the left 4 and Y's up 2. Then that triangle became this triangle after a rotation, and then subscript about point M, which had the coordinates 3, -4, and the degree was 90 degrees. So that's how I did it in GeoGebra, and that's how you can do it in future questions. Now again, you could have mapped any one of these points onto a different point. So there's many right answers to do this. I showed you just one way. And same thing here, I threw in part B of this question. How would you use properties of rigid motions to explain why the triangles must be congruent? Again, I go back to the top, and I did a translation and rotation. So I copied and I pasted, and there's that sentence. This is why those triangles must be congruent, because these two rigid motions maintain size and shape. So there you have it. That's video number 2 or video number 3. And you should be able to continue the remaining questions on this document.